Hi all, good morning. So, in the previous class, we have seen that some of notations, algorithms using GCD example. Now, we also saw informally some Python code in the previous class itself. Now, in today's class, we'll see some formal introduction to Python syntax. Also, we'll talk about the basic types, int, float, and all. Next, we see some assignment statements. So, this is how a typical Python program would be written. We have a bunch of function definitions followed by a bunch of statements to be executed. So remember that we said Python is typically interpreted. So an interpreter is a program which will read Python code and execute it from top to bottom. So the interpreter always starts at the beginning of your Python code and reads from top to down. Now, function definition is a kind of statement, but it does not actually result in anything happening. The Python interpreter merely digests the function, that means kind of remembers the function definition, so that later on, if an actual statement refers to this function, it knows what to do. In this kind of organization, the execution would actually start with the statement which is called statement 1 here. So first you will digest k functions and then start executing 1, 2, 3, 4 up to statements n. Now this is somewhat a messier program. There is no reason to do this, but anyway, Python actually allows you to freely mix function definitions and statements. And in fact, function definitions are also statements of a kind. It's just they do not result in something immediately happening, but rather in the function being remembered. One of the things that Python would insist is that if a function is used in a statement that has to be executed, that function should have been defined already. Either it must be a function that is built-in function or its definition must be proved. So it may use this kind of jumbled up order. We have to be careful that functions are defined before they are used. Also, jumbling up the order of statements and function definitions in this way makes it much harder to read the program and understand what it is doing. Though it is not required by Python as such, it's strongly recommended that all function definitions should be put at the top of the program and all the statements that form the main part of the code should follow later only, like we have seen in the previous slide. Now let us talk about assignment statement. But before that, what is a statement? The most basic statement in Python is to assign a value to a name. So we have seen some examples, and here are some examples. In the first statement, I is a name and it is assigned a value 3. In the second statement, j is a different name and it is assigned an expression 4 times I. So in this expression, the value of I will be substituted for the expression I here. So if I have not already been assigned a value before, Python would not know what to substitute for I, and it would be flagged as an error. So before using a name, we must always assign a value to that. When you use a name of the right hand side as part of an expression, you must make sure that it already has a valid value. And as we saw, you can also have statements which may really update a value. So when we say j is equal to j plus 7, it is not a mathematical statement where the value of j is equal to the value of j plus 7, but rather that the old value of j which is on the right hand side is updated by adding 7 to it, and then it gets replaced as a new value j. This is an assignment statement. This equality assigns the value computed from the right hand side given the current values of all the names. If the names given on the left hand side, the same name can appear on both sides. The left hand side is a name and the right hand side is a, in general, it is an expression. And in expression, you can do things which are legal. Given the types of values in the expression, so values have types. If you have numbers, you can perform arithmetic operations. If you have some other things, you can perform other operations. So what operations are allowed depend on the values, and this is given technically the name type. So when we said type of values, it is really specifying what kind of operations are legally available on that class of values, right? So the most basic type of value that one can think of are numbers. Now in Python and in most programming languages, numbers come in two distinct flavors, as you can call them integers and numbers which have fractional parts. So in Python, these two types are called int and float. So int refers to numbers which have no decimal part, which have no fractional part. So these are whole numbers. They could be negative, but these should be a whole number. So these are some examples of values of type int. You have 153, minus 45, 5672, 9356. All these are some examples of integer type. On the other hand, if you have fractional parts, then these are called as type float. Right? So as you can see here, 3.14 minus 9.81, 0.0003, 67.98456, etc. are the examples for floating numbers. Normally, in mathematics, we can think of integers as being a special class of, say, real numbers. So, real numbers are arbitrary numbers with fractional parts. Integers are those real numbers which have no fraction. But in a programming language, there is a real distinction between these two, and that is because of the way that these numbers are stored. So, when Python has to remember values, it has to represent this value in some internal form, and this has to take a finite amount of space. Suppose if you are writing down, say, a manual addition sum, you will write it down on a sheet of paper, and depending on a sheet of paper and the size of your handwriting, there is a physical limit to how large a number you can add on that given sheet of paper. In the same way, any programming language will fix in advance some size of how many digits it uses to store numbers, and in particular, as you know, almost all programming languages will internally use a binary representation. So we can assume that every number, whether an integer or real number, is stored as a finite sequences of zeros and ones which represent its value. Now, if this happens to be an integer, you can just treat that binary sequence as a binary number, and you would have learned it in school. So the digits represent powers of 2. Usually, there will be one extra binary digit 0 or 1 indicate whether it is plus or minus, and they may be more efficient. There may be more efficient ways of representing negative numbers, but in particular, you can assume that integers are basically binary numbers. They are just written as integers in binary notion. Now, when you come to non-integers, that is floating point numbers, then we have two issues. One is we have to remember the value, which is the number of digits which make up the fractional part, and then we have to remember the scale. So think of a number in scientific notion, right? So you normally have two parts when we use things in in physics and chemistry. For instance, we have the value itself, that is what are the components of the value, and we have how we must shift it from shifted with respect to the decimal point. So this says move the decimal point 4 digits to the right. In this example, if you can see, the scientific notation says 0.56734 multiplied by 10 power 4. That is, it is saying that, what is saying? Move the decimal point 4 digits right. So this first part is called the mantissa, right? And this is called, and the second part is called the exponent. So when we have the number in memory, if it is an int, then the entire string is just considered to be one value, whereas if we have block of digits which represent a float, then we have some part of it which is the mantissa, and the other part which is the exponent. The same sequence of binary digits, if we think of it as an int, has a different value, and if we think of it as a float, has a different value. So why float, you might ask? Float is an old term for computer science for floating point. It refers to the fact that this decimal point is not fixed. So an integer can be thought of as a fixed decimal point at the end of the integer. A floating point number is really a number where the decimal point can vary, and how much it varies depends on the exponent. So there are basically fundamental differences in the way you represent integers and floating point numbers inside a computer, and therefore one has to be careful to distinguish between the two. So what can we do with the numbers? So there are certain operations you can perform, certain operations that are legal in certain types. Well, we have the normal arithmetic operations, plus, minus, multiplication, which has a symbol, uh, what is this, star, right? And a division, which has a symbol slash. Now, notice that for the first three operations, it is very clear. If I have two ints and I multiply them or add them or subtract them, I only get an int. But if I have two floats, I will get a float. Division, on the other hand, will always produce a float. If I say 7 divided by 2, I'll get 3.5, right? If I divide 7 with 3.5, then I will get 2.0, right? So it doesn't matter if I use both integers or one float or both floats, the result will always be a float for division operator. Now in general, Python will allow you to mix ints and floats. So I can write 8 plus 2.6 or anything. So it will result in 10.6 or something, right? So now there are some operations where we want to preserve the integer nature of the operands. We have seen one repeatedly in the previous sessions, the remainder operator, right? That is the modulo operator. So here is an example. 9 modulo 5 will give you the remainder 4. And there is another operator here, that is a double slash, which is for floor division. So it will give you the quotient in integer form, right? So it is same as division operator, that is a single slash, but it will give you a float number. Suppose if you use this previous example, that is 7 by 2, by using this floor division, that is double slash, then the result will be only 3, right? 7 double slash 2 will give you the result 3, whereas 7 slash 2, that is the division, will give you 3.5, which is a floating point. I hope I am clear. Now there are some more advanced functions like log, square root, sine, etc. These are all built-in functions of Python, but they are not available by default. So if we want to use these functions in our program, we must include the math library. So there is a way to include this math library. So I have given from math import star, right? So this will import all the functions that are defined in the function in the library math, right? Now we have seen three concepts which are names, which are what we use to remember values which are the actual quantities which we assign to names, and we said that there is a notion of a type. So type determines what operations are legal given the values that we have. So the main difference between Python and other languages is that names themselves do not have any inherent type. I do not say in advance that the name I as an integer or the name x is a float. Names have only the type that they are currently assigned to by a value that they have. The type of a name is not fixed. In a language like C or C++ or Java, we announce our names in advance. We declare them and say in advance what type they have. So, if we see an I in an expression, we know in advance that this I was declared to be of type int or a float. Right? Now in Python, this is not the case. So let us illustrate with this example. So the main feature of Python is that a name can be assigned values of different types as the program evolves. So if we start with an assignment I equals to 5, since 5 is an int, I has a type int. Now, if we take an expression which produces an int, such as say 3 times 4, still I remains an int. Now, if we divide the value of I by 2, so at this point, if we had followed the sequences, so previously I was 12, if I divide it with 2, then I'll get the result as 6.0. Now that is a float value. Therefore, because the operation results in a float, at this point j is assigned the value of type float. Now, if we continue at some later stage, we take I and assign it to the value 2 times j. Since j was a float, I now becomes a float. In the interpreter, there is a useful function called type. So if you type the word type and put an expression and either a name or an expression in the bracket, it will tell you actually the type of the expression, right? So we'll stop here. We'll demonstrate these in the program. Then we'll continue with some other Boolean values and all in the coming classes. Thank you.